Hello everyone, today we are going to implement this character dissolving, disintegrating and blowing away in the wind effect. Here is the preview. Right, again the preview. Okay, so this is what we are going to work on. Okay, so I'll create a new project. This is Unreal Engine 4.06 using games category. I'll choose the third-person template because I need a skeletal mesh character. I don't need to include starter content. Don't appear. Okay, let's create the project. Okay, so this is what we have. The usual third-person template. And now let's go to the content browser and create a folder Niagara and create a new Niagara system using empty emitter template. Finish. I'll call it endless blown away. Okay, now let me open this. Here under emitter properties, I'll change this to GPU compute sim, and under particle spawn, I'll add initialize mesh reproduction sprite, and as the mesh I'm going to use 𝐂𝐚𝐽𝐻, and under particle spawn I'll add the spawn rate here, spawn rate. I'll set it to 50,000. Looks a bit too much. Let me reduce. Right. Then I'll add a velocity. $110. Okay. Let's add this into a mesh in the sea. Let me get the mannequin mesh here. Let's use this third-person idle. And Niagara particle system assign blown away. Right. This looks too big, so let's go here and set the scale to 0.3. This scale seems better. Okay, and also let's add some curl noise was. Strength. Right. Okay, this seems alright. And also let's add gravity. Since this is somewhat like a lightweight particle, I'll set the gravity to a lower value, and also I'll enable collision because this penetrates the ground, as you can see here, so we need collision. Right, now see, the particles fall on the ground. Now I think we should increase the rate now that we have smaller particles. Okay, so right now we need a way to make this character disappear from top to bottom, and also we need to make the particles appear from top to bottom. So for that, let me check the material used here. Right, this one, ml body. Let me duplicate this, ml body fade. Okay, here let's add this is the usual mannequin material. Let's add set material attributes node, and here I'll add set type masked, opacity mask, because this is a masked material. Now as the opacity mask, so we need to define a way to make the character disappear from top to bottom. So here I'll create a material parameter collection MP global. The reason to define this as a material parameter collection is because I'm going to use the same parameter in another material as well. So let's add a scalar parameter. I'm going to call it level. So this is the level that we need to make, that we define the visibility level of the character. So it's by default 0. Let me set something like 100, because the character height, if we are in the we are in 100 at 30. Right, so somewhere over here is 200. Okay, so let me set this as 200, and let's get that collection parameter level value. Also we can access world position. Here I'm gonna mask, do a component mask, and going to get the B value, that means X, Y, Z, the vertical value. Then here let's use a if node, and if as A, let's use this level defined in the MP global, and as B, let's use the output of this one, the vertical level of a particular pixel that we are rendering. And if A is larger than B, let's use the opacity as 1. Otherwise, let's set opacity to 0. Right, now apply, and here let me apply this material, male body fade. Now see, half of the character is invisible. And as I change the value here, you can see character start appearing and disappearing. Okay, but this is not smooth. So what we can do is we can, let's see, here instead of using 1 and 0, we can use a temporal dither node here. Yeah, 1 is okay, but for 0 let's use temporal dither, temporal dither AA. And here, as the level goes down, the opacity should, instead of going from directly 0 to 1, it should fade. So to get that fade in effect, I can subtract this level from the world position, the masked B component of the world position. So we will get, as the level goes down, we will get higher value here. And if I just directly connect this, still I don't think we would see any difference, because this alpha threshold we would see a fade in effect only if we have some value in between 0 and 1. Let me try. See, still we have a sharp edge. So to get rid of that sharp edge, I'll divide this by 100. Still no. Alright, let's add some value. Let's add 1 here. No, just some value 1. Right, now we should get the fade in effect. See, it's not fully transparent, we see a fade in effect now. Great. So now we have to use the same parameter to determine the visibility of the particle as well. How? Let's see, we are using the default sprite material. It's in engine content. Let me copy this to this Niagara folder so I can modify it. Let's copy, make sure not to move, copy, because if you move it or do any changes in to that material inside the engine content, you will see those changes in other projects as well. Right, so I'm gonna change this to sprite material fade. Okay, so here also I can use that same logic without this dither part. Of course we don't need dither here because this is not a this sprite material is not a mask material. I think it's additive, yeah. So let me paste, and let's multiply whatever the value here with the value we get from here. And here we don't need this subtract part, so we can set this as constant 0. And let's assign this sprite fade material as the material of the sprite renderer. Okay, and we'll see. Now we see only the below part, but actually this has to be reverted for the particle. So we can interchange this. Oh, because of this masking, we don't see the particles dropping, but we'll be able to fix it when it wouldn't be a issue when we implement this blown out effect. Right, now in order to implement this effect properly, let me put this back to 300. Oh, 300 is not enough. 100. Okay, and let's so actually this is not optimal because we are still spawning the particles, but this is just for demonstration, so I'm not gonna consider that here. So here let's create a new class using this third person animation character skeletal mesh. I'm gonna call it ch thrown away. Right, now here in the event graph we have the Niagara system here. Here let's set scalar parameter value in the employee global and the parameter name level. So let me promote this to a variable. As the default value, I'll keep 400, and then let's keep decrementing this parameter value. What should I call it? Let's call it level. Subtract this by 0.1 or maybe 0.5, and if the level is less than, let's say 50, let's deactivate the Niagara system. Here let me select simulate instead of play, because if I play I will be possessing this character. See, okay, this material is not considered, right? What if I just assign the same material? Would that be a problem? Yeah, that's a problem. Okay, but we can actually copy the same thing that we have done into this material as well. Oh wait, just logo. It's okay. Let's, as the parent, let's use fade. That shouldn't be a problem. Okay, and let's speed it up a bit. 1. Okay, so that's it. Here I think we can further optimize this effect, because as you can see here, when I get the particle here, the head is still visible. So I think if we speed up the fading a bit, we should get a better effect. So let's try 0.5 here. Maybe further down. 0.2. Yeah, that seems better. Okay, so here is the final effect. Alright, so I'm gonna stop this episode right here. So here, if you further increase this noise strength of the curl noise, you will get a much strong effect, much stronger wind effect. But I'm gonna stick with something like 400 here. Okay, so here is the final effect. Alright, so that's all, and thanks for watching. So as always, project files will be available for the download through Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.